Okay, so what is the question? Question is, we need to find integral sin nx dx. So, we have to use the y part here. So to do the y part, we don't have the second function here, right? So you can consider maybe second function to be 1, but that doesn't work here. Yeah, you might have right. So you have to look at the equation given, right? So accordingly, you break this into sin x, sin n minus 1 x dx. This is the catch. How do you understand that? Because if you look at the first term will show you sin n minus 1, that term is there. That is the clue. Clue is already inside the question. So what I'm going to do, I'm going to consider this to be u and this to be v prime. So if this is u prime is going to be n minus 1 sin n minus 2 x, so sin becomes cos. This. Then so you are going to integrate this. So if you integrate this one, v is going to be minus cos x. Right? So you can write I to be now uv, right? So u is this, v is this. So it's going to be minus cos x, then this is v, u is going to be this guy, sin n minus 1 x minus integral, then v, which is minus cos x, I'm going to make it plus because of this minus and minus, then cos x times u prime. So u prime has n minus 1, so I'm going to put n minus 1 in front. Then this cos and cos is going to be cos squared. You get sin n minus 2 x dx. The first part is done. Now, how to simplify this? Right, so you have to find this integral. So you can see cos squared here. You can see sin n minus 2. So I'm going to write cos squared to be 1 minus sin squared. Right? If I do that, I can see sin n to the n minus 2 x here, and then sin n is coming between these two. That I can see. This vision is important, and that's your experience. So what will happen? I is equal to minus cos x. So I'm just copy pasting here. Sin n minus 1 x plus n minus 1, right? So then this is going to be integral sin n minus 2 integral sin so here sin n minus 2 x dx, then minus you have integral sin x dx, close the bracket. Okay. So this is n term, right? So this is n. So you say this is in because you are using the generalized n. So this is in here. Then if this is in, so when you have n, when you use n, so n pops up here. So this is nothing but now n minus 2, and this is nothing but in. So you can easily write in is equal to minus cos x sin n minus 1x plus, here you get n minus 1 in minus 2 minus you get n minus 1 in. So I'm going to bring that term here. So if I do that, I get in plus n minus 1 in is equal to, right? So here you get minus cos x. I'm just copy pasting now, plus n minus 1 in minus 2. So now you can see here minus in plus in gone. So it's going to be in. So to isolate in, we are going to divide the whole equation by n. So it would be minus 1 divided by n cos x sin n minus 1x plus n minus 1 divided by n minus 1. Done. Okay. So if you really look into it, it's just 4 5 steps. Okay.